Hey there, students. In this lecture, I'm going to focus on the accomplishments of Copernicus and Galileo, which I'm calling a scientific revolution. Now, these are two of the most important figures in the scientific revolution, and also the story of Copernicus and Galileo is really kind of a microcosm of the scientific revolution in general, which I'll explain kind of how we can generalize what's going on into the values of the scientific revolution in early modern Europe. So first of all, let's start off with cosmology. Now, cosmology has to do with how we see the cosmos, the way that we look at what is beyond the world and where is the world in the sense of what's beyond us. Okay, so how do we look at that? By the way, Janessa and all of your friends in Cleveland, shout out. So the ancient cosmology is based on the theory of geocentrism, that the Earth is at the center of the universe, that the Earth stands still and everything else revolves around it. And this comes from Ptolemy, who was a 2nd century AD Greco-Roman Egyptian scientist. And this is what, what you see in the early modern period in Europe is a reverence for ancient authorities. Like, you think about today, if somebody was expert on something 30 years ago, they're no good now when it comes to science, all right? That really, our science and our technology, they update very frequently. 30 years might have been a stretch, but still, you get my point. But there was this reverence for ancient authorities that although Ptolemy was an astronomer in the 2nd century AD, like almost a millennium and a half ago, he's still the authority. Now, the other thing is that Aristotle, he was a Greek philosopher and scientist and was the authority on physics, even 2,000 years afterwards. Now, today, we still consider Aristotle to be a very smart guy, but he is not our authority on physics. There are a lot of other things, such as his politics. That's something that I still teach in my classes, but we don't consider Aristotle to be the end-all, be-all when it comes to physics. And then, of course, the Bible is the ultimate ancient authority. When we look at the Bible, we see a justification for a geocentric cosmos, such as when you look at the book of Joshua. Joshua was in the process of destroying his enemies, the 5 Amorite kings, and he asked his God, can you keep the sun up a little longer? Because I need to kill some people. And Joshua's God responds by making the sun stand still. Now, if you're thinking about a geocentric cosmos, okay, the type of thing where, okay, the Earth is just right here and everything kind of goes around it, then that's not a big deal, all right? Because God's just like, oh yeah, sun, stand still for a second while Joshua destroys his enemies. But if you look at it from a heliocentric cosmos and tie in the laws of universal gravitation and all of that kind of stuff, it becomes pretty problematic, all right? So the biblical cosmology is not the same cosmology as, you would find us talk about today. You can find drawings of the biblical cosmology on the internet that are really, really interesting. So here is a geocentric cosmology, not that they believed in flat Earth or anything like that. They knew that the Earth was round and everything, but everything goes around the Earth. The sun, the stars, the planets, everything. That the Earth is at the very center of the universe. And doesn't it feel good to be at the center of the universe? Which that's something else that I'll hit on shortly. So the scientific revolution was a period in the 16th and 17th centuries where there were fresh inquiries into what they called at the time natural philosophy, all right, which today we call science, but they considered science at that time a branch of philosophy. So if you're ever looking at a primary source document that mentions natural philosophy, then that is having to do with what we would today call science. And so Nicholas Copernicus in the 16th century was a Polish priest and astronomer, and he posthumously published on the revolutions of the heavenly spheres. Now, by posthumously, this is meaning at the time where he is dying. People used to think in Greco-Roman medicine that you had humors in your body. So post-humor, all right, the humors have all gone out and you can't live anymore. But he published this book posthumously because he had a feeling that it was going to cause a stir. So Copernicus is trying to play it safe. He didn't want to say anything while he was still alive, but it's like, well, since I'm about to die anyway, maybe I will, just let people know what I've been thinking, these mathematical calculations I've been putting together. So, heliocentrism. This is the idea that Copernicus is advancing. Now, there was at least one ancient scientist who put forward this theory, but this was not the prevailing view. That Copernicus is putting the view out there that the Earth revolves around the sun. So, it's pretty much turning everything people thought was real on its head. After all, anybody ever seen the sun come up? Come on. I mean, it's pretty obvious. I mean, it's like, come on, I don't feel the Earth moving or anything like that, right? And here is a heliocentric cosmology, where we see the Earth rotating around the sun as one of many planets rotating around the sun. So it is a different way of looking at the solar system and the universe as a whole. So as far as what's at the center of the universe, there was Ptolemy, who advocated geocentric theory. There was Copernicus, who advocated heliocentric, sun-centered theory. And then Galileo, who confirmed heliocentric theory. And this is important because when Copernicus is playing around with his mathematical calculations, he is just putting a theory forward that something in science cannot be regarded as true unless it can be confirmed by direct observation. And that's why Galileo was so important. So Galileo Galilei was an Italian astronomer and physicist. And there are a lot of things that Galileo did. It's not just his telescope, but he was also somebody who updated our understanding of physics. If we're going to look at Aristotelian physics, first of all, free-falling objects. That Aristotle said that heavy objects fall faster than light objects. Think about it. If you drop a bowling ball and a sheet of paper, the bowling ball is going to land faster than the sheet of paper. Of course, there are a lot of other reasons for that, like friction, a bunch of other sciencey stuff that I don't really understand that well. And then as far as acceleration, objects fall at a constant rate with no acceleration due to gravity. And Aristotle's way of getting at this stuff is logic. If you just think about this in your head, all right, well, heavy objects will fall faster than a lighter object, and they'll just fall at the same rate. I mean, acceleration due to gravity isn't something that we just kind of think up. It just doesn't seem logical to us. So Aristotelian physics were based on logic. Now, Galilean physics, when it comes to free-falling objects, Galileo said heavy objects fall at the same rate as lighter objects, and they accelerate as they fall due to gravity. Now, the way that Galileo came to his conclusions was through empiricism, through observation and experimentation, which is really key to understanding the scientific revolution and the Enlightenment. And as far as his experiments were concerned, he went to the top of the Leaning Tower of Pisa, and he performed his experiments atop this tower, where, he could very easily drop stuff, and he can measure from different places how fast something's falling, whether the heavy and the light object fall at the same rate. And what he did was he got a cannonball and a musket ball. Now, this is something that they have the same, they're made of the same thing. One's just bigger than the other. And when he dropped the cannonball and the musket ball, they both landed at the same time. So then Galileo made improvements to the telescope. He developed this refracting telescope. I have no idea what any of this stuff means, but it's important because it allowed Galileo for the first time to see things that other people had not been able to see, to observe things in space that other people had never been able to observe. First off, Galileo was able to look at the moon, and he was able to see lunar mountains and craters. And before Galileo, Aristotle had said that the moon and all other objects were made out of what he would have called the fifth element, all right? That they were made out of this fifth element, that they were really metaphysical objects. And so what Galileo is seeing here, there are mountains on the moon, there are craters on the moon, that the moon is a physical object. just like anything here. So this turned conventional wisdom on its head. He was also able to discover the Galilean moons. Now, he discovered 4 moons that were orbiting Jupiter, which was very important because it demonstrated that there are other bodies besides the Earth that other things revolve around. So this is really key to understanding Galileo's cosmology. And there are several notes that he's making about these 4 Galilean moons. And then Galileo looked at the phases of Venus. So he's able to observe Venus over time, and he's able to see that this is not something that's revolving around the Earth along with the Sun. This is another heavenly body that is also revolving around the Earth just like we are. Galileo's telescope is a prime example of the idea of technology driving science. When we have new technologies that are created, then we're better able to understand the universe and update our scientific understandings. And that's one of the reasons why you didn't see a lot of movement in science before this time compared to, ancient Greco-Roman science, because you didn't have these new technologies that enabled people to look out into the universe and see what was out there. This is also an example of empiricism, that we come to truth based on what we observe and what we see, what we sense, rather than relying on traditional authorities. When we look at it empirically, then if we see something that goes against our traditional understanding, then we update that understanding based on what we see. Another thing about empiricism is it establishes facts rather than theories. So while Copernicus put a lot of calculations out there and said, I believe that we revolve around the sun, that things are heliocentric, he didn't have direct observations to back them up. So that's another thing about science, that until something is backed up with direct observation, it is a theory rather than a fact. Galileo wrote a number of books, one of them being Sidereus Nuncius, which hopefully my Latin was at least passable there. But in English, the Starry Messenger. That's probably going to be your better bet for writing down what he wrote. But in the Starry Messenger, we can see here that Galileo is drawing his observations of the moon. That, look, the moon is not made out of a fifth element. The moon is made of the same sort of thing as the Earth. It's got craters, it's got mountains, and all of this other stuff. That the moon is a physical object. Another book that he wrote, now what's interesting about this, for those of you who've been studying humanism, is that the Starry Messenger was written in Latin. But then we look here at his Dialogo. This is written in Italian. And the significance of that is that Galileo was writing his dialogue for everybody. He wanted everybody to be able to read it and understand it. And in this dialogue, in the Starry Messenger and his dialogue, he is putting out this idea of heliocentrism and justifying it versus the old geocentric view. Now, of course, Aristotle believed that the heavenly bodies were perfect spheres. The church taught that biblical cosmology was correct, that what Galileo was saying not only went against the classical authorities, but also against the religious authorities. And when you put this into the context of Italy at this time, in the very late Renaissance, that these are both great authorities. When you think about the classical and the Christian traditions, that Galileo is going against both of them, so you can see why there was such a negative reaction to what Galileo was saying. And so Galileo has contradicted the biblical account and contradicted the classical account of what the cosmos looks like and where is our place in the universe. Galileo was brought before the Inquisition, before a church panel, in order to justify what he said, which this Inquisition eventually ordered him to recount, which he did, and his book was placed on the Index of Prohibited Books, something that existed until the mid-20th century in the Vatican. And some people have used Galileo's trial as evidence of science versus religion, that Galileo ended up having to recant. He spent the later years of his life under house arrest, but is there always a conflict between science and religion? In this case, the religious authorities were very rigid in defending something that really isn't a fundamental necessary ingredient for Christianity. Jesus Christ is no less the Son of God just because the earth revolves around the sun, but the church certainly seemed to think so at the time. And when you look at the tomb of Galileo, you see that although Galileo was not popular with a lot of church authorities, that Galileo was obviously a devout Catholic. This is a very, very Catholic-looking tomb. And then when we look at Copernicus, Copernicus himself was a priest and a 19th century artist painted Copernicus having conversations with God. That really what makes people look out there is a curiosity about what is beyond us, something that any devout Christian would be concerned about. You know, what is the substance of this created universe that we live in? And then we look at Francis Bacon, who wrote that a little philosophy inclineth man's mind to atheism, but depth in philosophy bringeth men's minds about to religion. So one thing to note about the scientific revolution is, yes, they are challenging authorities, they are challenging the teachings of the church and biblical cosmology, but they are not meaning to attack Christianity. They are not meaning to say that they are no longer Christians, although they are interpreted as going against the church. So that's a nuance there, that when you go to the Enlightenment, the philosophers of the Enlightenment openly challenge the church. But these people really aren't. The church is taking issue with some things that they are writing and teaching, but they are not intending to challenge the church or Christianity. And really, when you think about why is it that people responded so negatively, I think about it in the same context as evolution, that when you have this scientific evidence that may say one thing that undermines our place in the universe, people tend to react toward that evidence in a negative way. Now, when you think about it, if you put this in the context of late Renaissance Italy, remember Pico della Mirandola, who said that God had created man at the center, that we were the most important of God's creations. And this made people think, well, if we're not at the center, how can we be sure we're the most important? So human beings tend to resist any scientific theory that might be seen as cheapening our place in the universe, our primacy in the universe, because we love to think that we're number one, and we don't like to part with anything that would make us feel like we're number one. So let's go now quickly into the legacies of Copernicus and Galileo. The legacies besides Shrek or whatever, okay? So let's look at what happens there afterwards. Johannes Kepler was a German mathematician and astronomer who came up with the laws of planetary motion. And what Kepler did, building upon Copernicus, building upon Galileo, another theme of the scientific revolution is this collaboration that's possible thanks to the printing press. So he comes up with these laws of planetary motion where he said that the planets travel in elliptical orbits, and the sun is one of the focal points of this elliptical orbit, and the other focal point is, well, something else. Ask your physics teacher if you want to know more about that. Major key alert! It could be said that Kepler gave the first elliptical talk. And today, Kepler is remembered with a space telescope that's named after him. This Kepler Space Telescope is producing all kinds of great images of what lies beyond. And then there is Newton's law of universal gravitation, which was dependent on Kepler's laws. So you have Copernicus, who laid the foundation for Galileo's observations, then those laid the foundations for Kepler's laws, and then here comes Newton, who says, hey, I've got a law of universal gravitation that applies to the whole freaking universe. So what Copernicus started, because of this communication mechanism that develops here in the scientific revolution, that it becomes the basis for a lot of much more groundbreaking scientific theories. And that's that. I've got a couple of other lectures on the scientific revolution, lots more about the history of philosophy and science, and about intellectual and European history. So if you liked what you saw, subscribe to my channel, tomrichey.net, social media, Twitter, Instagram, all of that stuff. I'll be back soon with more videos. Until next time.